Hello, welcome. My name is Gavriel Harbater, who am I? So, currently, professionally, I have a company called Santa Cruz Software. We're in the field of creative design, creative programming. Which basically develops applications for the creative market, so Adobe programs, et cetera, and so forth. In the past, I've been an Adobe Adobe community professional. I was a moderator on the Adobe forums. I'm a member of Apache and the Royale and Flex Apache teams. So, last time we had 10 random facts. So, here's some random facts. I'm a second-generation ocean lifeguard. I lost one swimming race in my life, who ended up being my Schwer's something or other. And don't challenge me to a swimming race because I'm not gonna accept. My great-great-grandfather, well, he wasn't really a Cossack. He was a Kantonist. He actually got married to had a whole family before he came back to Judaism, and they died out in a plague. Came back to his old town, and they all closed their doors and windows when he came because they were all scared of him. I go by the name of, professionally and online, I go by the name of Harbs. My father went by that nickname, my uncle did. I have various cousins that do, so if you see Harbs around there, then we're probably related. I've always liked Boy Scouts, so I was very impressed when our last speaker said he was an Eagle Scout. So, I live in Kiryat Sefer, and yes, I work. So, like I said, I work in the obscure field of creative developers. It's an interesting field, but I'm not going to dwell on that right now. I come from zero programming background, meaning that meaning when I started, I didn't know what a loop was. I didn't know what a variable was. The first programs I wrote, I didn't know what data structures were. So everything was an array. So yeah, I kind of winged it. I have a fascination with the fonts and text composition. I actually programmed a font, and I work with actually reading and parsing fonts as part of what I do. And I don't like speaking or making lists. Yeah. So, it's like I mentioned in 2004. Okay, I didn't know what a variable or loop was. I kind of fell into it because I needed to do some things that InDesign didn't do. So. I learned a little bit on the Adobe forums. So a guy named Dave Saunders wrote for me my first script over there. It was actually for drop words, okay, if anyone knows what those are. And so from there I kind of learned the basics, got a lot of help from the people at the Adobe scripting forums, and I eventually became one of the moderators there, and I ended up helping other people there. So that was kind of like my first introduction to the concept of open source. It wasn't really open source because it was whatever, but it was an online community of people helping each other with code. So eventually I realized that the stuff that I was building for myself might be interesting to other people, so I started selling it. And it's in, was it CS4, I think, Adobe introduced the concept of creating panels in their applications. Those were built with something called Flex, which was basically, you'll hear a little bit more about it soon. So that was my introduction to a little bit more structured programming than I was used to. Yeah, like I wrote here, changed the way I programmed. 2011, that's when things started going a little bit wonky with Flash. Adobe donated Flex to Apache. The next year, I became involved in Flex at Apache. The next year or so, I became an Apache member. Then we started work. The work was started. I didn't have to do much with it at the beginning. But work was started in Flex to make it compatible with not just. It was originally a framework for Flash. Who here ever programmed in Flash? Not a whole lot of people. Okay. For those that didn't program in Flash, it was actually probably one of the nicest programming environments at the time. We had a tremendous amount of. It really had a very nice API. You have very nice capabilities. Problem with Flash was because it was so easy that a lot of people made bad programs. So if you take a bad program, put it in a browser, and you run it, so it's going to make your web page very slow. So also computers and networks were not really strong enough for most of the stuff that Flash was doing in those days. HTML wasn't really an option then either. So that's kind of how Flash got a bad name. But as a programming environment, it was really a very nice environment. There's a lot of things that you were able to do in Flash that is still very difficult in HTML today. But it was obvious at that point that Flash was on its way out. Targeting HTML was important. The framework that Flex was built around is a very good framework, very well designed framework. It was by far the most popular framework at the time. So work was started to cross-compile that to JavaScript, which was not very, wasn't a big chiddush because ActionScript, which is the language that's written in, is a version of ECMAScript. So what it's called today Royale, it was a split from Flex in 2017. Okay, so at the time we had a rather large application, which is basically ran the equivalent of InDesign, which is a design program in the web. So we needed to have accurate rendering of text, which is faithful to what you're going to get in InDesign server. It was basically a full design or partially limited design application online, very big code base. Would have been a nightmare to migrate it to JavaScript and HTML. To make things worse, basically none of the web technologies for rendering fonts were useful for our purposes because we needed to render it the way InDesign is going to render, not the way browser is going to render. You need to be fully cross-browser compatible without any differences between browsers, which is basically almost impossible if you're using the native HTML technologies. So we need to build our own text engine. Somewhere around that time, we also created an Angular application, which was a much simpler application for our purposes, and quite frankly, I did not like it. Not to put too fine a point on it. I didn't like the way the scopes were bound. I didn't like the idea of writing loops in HTML. I didn't like lots of things about it, and I was not prepared to build a large-scale application using Angular. Many of the other options that are available today weren't available at the time. I might have looked into more of them if they were, but Flex was basically what it was built in. This was being cross-compiled in JavaScript, so Flex.js, as it was called at the time, was basically what made sense. So at that point, I became very involved in the development of Flex to be cross-compiled into JavaScript, and I'm probably the most active member of the team today. So, what is the advantages of Royale? I'm going to go through it very quickly. So one of the problems with HTML is HTML is not an application markup language. It's a document markup language, and that might sound like a small difference, but it's not. It's not really designed for marking up anything other than visual, anything that's not visual. It's the ability, so logic in HTML is not. It's difficult to connect the HTML to the logic, which is basically one of the problems that most of the frameworks deal with. That each one has their own ways of solving that problem, and if you have similar components that might have the same name, declaring them in HTML is very difficult. MXML, which is the markup language that Flex uses, was designed from originally as an application markup language. What are the advantages of Royale? Number one, it's unopinionated. So most frameworks that I've seen are very opinionated. How things have to be rendered, when things have to be rendered, what design patterns you have to use, what does your markup look like, what should be in markup and what should be in code. Royale doesn't have any of that. Royale uses ActionScript. For those that are familiar with TypeScript, it's basically a language that has type safety, optional type safety. But unlike TypeScript, ActionScript actually has type safety in the runtime. I'm not aware of any other web framework or language out there that gives you that. So like, what does that give you? Basically, I don't know if anyone ever wrote a binary search, for example. So it's like one of the rites of passage is writing a binary search and have it not working because your index is a float and it's not an integer. So basically, if you declare an integer in ActionScript, it stays an integer, and you can't get bugs like that. So, another reason I was a Royale, I was familiar with Flex. I was running the Flex PMC. I was able to control I was not able to control, but I was able to contribute to the direction of the project. And another thing that I was very concerned with was performance. One of the problems with many of the JavaScript frameworks is that performance is difficult. It's very difficult to get high performance out of the JavaScript frameworks because of the way they're built. Because of the type of application that I have, which basically has to, which has to render text, render graphics, and et cetera, on the fly, performance is extremely important to me, and I believe that Royale has unparalleled, as performance that no other framework would. Okay, so. What exactly does MXML, what does the Royale application look like? So I'm just going to go through the very basics to give you an idea of the environment that I use every day. So this is a complete Royale application. Okay. For those, I don't know how many people are familiar with XML, but XML has a concept called namespaces, which basically you can declare a prefix for your XML element, and that says that this XML element belongs to a specific namespace. So MXML uses uses namespaces very extensively. So you can have custom namespaces, you can have built-in namespaces, you can create your own libraries that use namespaces. So this is a Spectrum application. So Spectrum is an open source component library that I built that's available on GitHub. The main application, you declare your namespaces, properties, and event listeners. You have a script block. Script block is where you have all your code, or at least all the code that belongs to this file. You declare your view, and that which is basically so what I write over here, children beads, etc., is basically anything else that you have related to your application you could declare in there. I'll get to that a little bit more in a minute. So here I declared view. So if you see so this little view, main view over here. So the namespace view points to view, which is basically a folder in the project, and that makes all the components within that folder available to MXML. This is the view file. Basically, it's subclass is Spectrum View. Again, you have your namespaces and event listeners. Script block, which we'll look at in a minute. You have a style block, which we'll also look at in a minute. Then we have something called beads. Beads is basically beads is a concept that was created in Royale, which is used for composition. So every good framework has some way to compose things where you don't have to have inheritance. The way Royale does it is there's something called strands and beads. So strands are basically, imagine you have a necklace, and you take a bead, you put it on the necklace, you take another bead. So basically your necklace is then composed of all these beads. The beads have no connection and don't necessarily have any connection between each other. The strand doesn't know anything about the beads that are on it. But the fact that they're connected allows communication and allows indirect interaction. So basically, within these strands, so a view is a type of a strand. You declare your beads. The bead we're declaring over here is a router. Below the children of this is we have a flex container, which is basically wraps flexbox functionality, and we have a list and a div. Okay. So let's just take a look for a minute at our script block. So Royale uses Java style. So this is ActionScript code. ActionScript is a form of ECMAScript, which has type safety, like I mentioned earlier. Imports are done using Java style imports. ActionScript has a feature, has metadata as a feature. So over here, we're using the bindable metadata to make this variable bindable, and what that does is basically if you change this variable later, whatever it's bound to will be automatically changed. There's other metadata. I'm not going to get into that right now. So then we have a couple of functions over there. Init is an event listener. One of the features of Royale is you don't have to worry about this. This is always correctly bound without you doing anything. That solves one of the major problems in JavaScript. So and we have two functions over there. This is basically our router logic. I'm not going to go too deeply into exactly what it does. It's pretty self-explanatory. Okay. So one of the interesting features of Royale, so you have standard JavaScript, right? So, I'm sure everyone recognizes all of this stuff. Just standard JavaScript. Then you have something like this, which is CSS. What did I just say? Yeah. So it's standard CSS. Then we have something like this, which is not standard CSS. But so CSS is actually an interesting feature, which in web technologies was only taken for visual components. The concept of cascading style sheets is not necessarily limited to visual. You can have cascading anything really. So one of the features of that was originally in Flex and in turn is in Royale is the ability to declare functionality, the ability to declare beads. You visually declare pretty much anything that can be applied via hierarchy. So if you have, for example, if you have a class that inherits from another class, you can declare a default bead on the parent class, and if you don't declare anything else on the child class, that'll automatically be applied. So, for example, in this glyph list over here, normally in Spectrum you have automatic keyboard navigation. In that specific case, we don't want keyboard navigation. So we just declare via CSS that it shouldn't use keyboard navigation, and that's that. So this is a very powerful feature. And so one of the things about the CSS in XML is you can either declare it in the same file, so you don't actually have, so you can keep so if you have a relatively simple component, you can have your markup, your code, and your CSS all in a single file, and it makes things simpler. When things get more complicated, you can obviously pull it out into a separate file, but the ability to keep it in one file is a nice thing to have. So now I'm just gonna dive a little bit deeper into one feature, just to give an idea of how it works and how you actually build it and what this all is. So this is a router for the Spectrum demo application available online, and this is the full router with the components closed, whatever you call it, just because there's so many of them, so it's not going to fit on the screen. So basically, what this does is lets you, a router. I'm sure everyone here has used a router. If you've written a web application, lets you route the hash of the URL to specific components. And this application has two different types of routes. One route is the URL parameters, and the other one is the URL path. So for example, if you specify, you can specify the theme of the application, darkest, lightest. You can just specify the size. And those are handled by parameter root. And the components, which is basically the pane, is handled by the component root. So what's interesting here is this is markup over here, but it's not actually visual. Okay, this is a router. This is not a other frameworks also have this but so by default MXM markup is visual. If you want it to be or it can be visual. Okay, you can specify specific properties of things in the markup as well. But by default, it's going to be a visual component. In the classes that this inherits, we declare the default property of beads and routes to change the default behavior. That way, we're able to just declare the routes and the routes, the router, the subroutes, and the specific routes within the routes. I'm not even sure the correct term of that is, as direct children. Naming is not an issue. Okay, right. So, so the init bindings is the same as our event listener. It could be the same as another private private function in a parent class. It doesn't matter. That just all works as you'd expect it. So, this application over here has 80 routes, which is quite a lot. Looks a little bit weird, because you have to declare the name. Basically, the component name is the path. So the way I have it structured over there is you have views, which has within it panes within it, a whole bunch of different panes that get applied. So basically, it's the class name, but the compiler checks this, and the ID lets you know if you misspell something over here. So there's really no danger of misspelling things over here. Despite the fact there's 80 routes and everything is reloaded at initial load time, the application still loads instantly, like you'll see soon. Okay, so how does this work? Okay, for those that might have heard me arguing in the past, they know I don't like magic. This looks a little bit like magic, so I'd like to show exactly how the router was implemented in Royale, so you can see it's really very, very simple code. So again, we mentioned the concept of strands and beads. Strands and beads is basically a strand. Like I said, it's just a class. You set a bead on a strand. There's an I-strand interface. Very few methods that you need to implement in order to have a strand. Pretty much just add beads. When you add a bead, so the bead sets the strand on the bead. So the bead then has a reference to its strand. And the strand has an indirect reference to the beads because it has a reference to all. It's an array of all the beads. You kind of loop through the beads. You can find a bead, but it doesn't keep direct references to a specific bead. So what does our router look like? So our router looks like so number one. Okay, so let's see, we got over here, on the top over here, to declare our default property of beads. That lets us declare children within our router, very simply, okay? Over here is event metadata, okay? So this basically, all this really does is it gives code completion in MXML in IDE to let you know what events are available, what type those events are. So these are just standard events, but you can declare the type of event anything you want. And those types are checked. So this is actually a bead over here. It extends a strand, but it also implements a bead. So this a strand and a bead is not mutually exclusive. You can have nested strands and beads. This is actually a bead, a strand which is also a bead. How does it work? Really very simple. Okay, so when we set our strand, okay, we add an event listener to the window, and we then call later, which is just basically a shortcut to a function, to call another function asynchronously. So basically, this allows the application to load. Once the application finishes loading, we then call our init function, which we have over here. Okay. So on init basically loops through our beads. We add all our beads. Every router, okay, just because, you know, for a router to work, it has to have something that actually reads the routes and writes the routes. So every router has to have an iPath route bead, which is an interface for a path route. So if we added one with our beads, we're good. If not, we need to add one. So basically what this does is it uses that CSS lookup that we mentioned earlier. And if we don't have one, finds the default and adds that. One of the things we need to do is initiate bindings. So if we if we declare something in XML, so we have bindings which automatically applies properties. We need to parse the bead, parse the hash of the URL, and then we tell the beads to do other things, which basically we just dispatch a couple events, right? So we dispatch an event of state change, and we dispatch an event of router complete, which is basically state change just tells all the routers that the state changed. If they need to do anything, whatever they need to do, they can go ahead and do it. And route complete if something needs to be done when the route is done. This is the rest of the class. Okay, so this class is divided into 3 screens because it's somewhat large. But the route state is basically holds the state of the route. So basically, this is a holder for basically for the beads to be able to set the state. So each bead might set a different part of the state depending on what they're doing. So that state needs to be set in the strand. So the strand doesn't really do anything with it. The beads change the state of the strand. So set state dispatches an event which tells the beads that hey we need something calculated. Go ahead and figure out what you need to figure out. I don't care what it is, but give me the results. And then we just basically standard, where is that? Window history, push state, which is a standard JavaScript API to push our state. So we saw this worked in MXML. How do we do that? Basically, these lines of code over here is basically all you need to do is to turn an ActionScript class into something that can be used as MXML. The magic kind of happens here in the MXML data interpreter, which basically takes what the compiler turns an XML file into, parses it out, has a standardized structure, parses it out, and creates a JavaScript object based on that. That was our router strand. These are our route beads. So this is the base. Okay, basically there's 2 functions. Now one listens to the route state and listens to populate the hash. Route component, that was one of the beads that we were using. That subclass is path route bead. Okay. We declare our routes as the default in XML. We listen to our state change, if you remember, was dispatched by our strand. We loop through our routes, we set the default, add the components, remove any existing components, and that's basically all there is to it. Okay, fine. So that's the general idea of how strand and a bead, very quickly ran through it. But that's the idea of how strand and a bead beads work, and this is pretty much how the entire framework of Royale is built. There's simpler strands, beads, it's more complex strands and beads. There are strands that have 7 or 8 or 9 or 10 beads. There are those that have 1 or 2 of them. But that's basically the idea. The idea is decouple the logic the behavior of the components from the actual components themselves, which basically gives you the ability to easily compose everything. So what does this give us? Like I said, we have one major paradigm that's applied across the framework. That's the only real unique thing that you have. I don't know, only, but it's the only major thing to get used to in Royale that I'm not familiar with anything totally similar to it elsewhere. But it's applied across the framework. Once you get it, it's not hard to get, then you understand how everything works. We have easily declaratively composable pieces. So basically each component is completely self-contained. You don't need anything else in the framework for it. None of the frameworks use it. You don't need to use any centralized logic, anything like that. That makes it easily composable. Extending CSS lets us cascade anything we want. Like I said, the components are completely self-contained. Right, the entire component is each part of the application is really totally self-contained. Nothing is dependent on anything else, and that allows you to really swap things out at random. Okay, you could take a piece from one component set and a piece from another component set. You can build your own, put it all together, and it all just works. Another major thing that we does, like basically the undercurrent of Royale, is something we call pay-as-you-go, which is basically you only get the code, you only compile the code, you only load the code, and you only run the code if you need it. So anything that's not needed is not loaded, and that goes for everything. And these are very simple concepts. You don't need to learn. You don't need to learn complex things to get to do this. So one of my main concerns is speed. So lots of frameworks speak about speed, how close they are to vanilla JavaScript. Well, I don't have the metrics to prove it. I have anecdotal evidence, but I'm pretty sure that Royale is faster than vanilla JavaScript. This application that I was just showing the router for, cold start takes between 40 and 450 milliseconds to load from initial application till it's usable. When you route from one component to another component, the worst case is 125 milliseconds. Normally, it's about 20 milliseconds to switch from route to route. As a comparison, Spectrum, which is the framework that I'm using, Adobe created their own Spectrum set, which is built based on React. They originally had a version of it which kind of loaded everything up once. It was so slow you couldn't use it. They broke it up into pieces, so it's loaded, only the pieces as you need them are loaded. And now it's usable, but there's a visible delay every time you change routes. The initial loading of the application is slower than the entire application using Royale. Okay, so that's nice. That's a nice sample application that shows the component set. What about a real application? So I have an application, so let's get an idea of the scope of the application. It's literally hundreds of thousands of lines of code. It has an entire font parser, which parses fonts, open type tables. It has an entire text framework library, which is basically a fork of the original FlexTLF, which is a pretty huge framework, which handles all the selection and text selection, text replacements, and rendering, and et cetera and so forth. Text rendering and a library. Framework which loads XML, all the business logic, everything, including all the framework code, everything compiles into about 600 kilobytes. Jesus, okay? This entire application is the size of what you talk about when you discuss frameworks, including all the framework code, okay? First paint on this application, which is, like I said, very, very complex, is less than half a second. The rendering of the application step of it, which again is quite complex, is 220 milliseconds. The working state of the application, which has to load a ton of assets, so it has to load a document, which is written in XML. One of the reasons I picked Royale is because XML processing is extremely important to me, because I have to read and write XML documents as part of our system. So the working state of the application, including downloading all the files and the assets and the text and rendering the text and parsing the fonts, and so on and so forth, takes about 4 seconds. Just as a reference, the original Flash application that we were optimizing from took somewhere between 20 and 30 seconds to load. Fine. Okay. Enough about Royale. I'm sure that was interesting, but most of you are not using Royale, or maybe I'll convince you. So let's discuss some other interesting topics. Okay. So as part of developing Royale, I had to learn a lot about web frameworks. What makes web frameworks tick? What's good about web frameworks and what's bad about frameworks? So I don't know how many people here recognize this book. This definitely dates me. Yes. Okay. This was a spin up. Yeah. Okay. So I'll skip the book part, but this was a very difficult book to read. There's a very big difference between web pages and web applications. Okay, a web page, okay, which is an HTML document, is a document. A web page application is an application. The most important thing about web pages is content. Web apps, more important is the behavior. Separation of content and styling is important for the web page because your content doesn't have the styling. Content's the content. Web app, self-contained components is a much bigger concern. Consuming the information is important on a web page. The interaction is much more important than an application. Your content comes as a stream if it's in a document, so it lends itself to the HTML structure. Applications are a lot of disconnected data. In a document, so you can load because it's serial. You can easily load in stages. With an application, there's a lot of interaction, so interactivity is much more difficult. Generally, you're going to have less business logic in a document than you will have in an application. So the challenges in a web framework are, number one, HTML is very bad for logic. You need to control a view, which is very difficult. You need to connect your markup with your code, which is a challenge. Parsing HTML is slow. Yes, it's quicker to programmatically build a web page than it is to load an HTML web page in the browser. Okay, most people don't know that, but it's significantly quicker to build it programmatically than load it in the browser. Easily usable components. This is what everyone discusses, which is very difficult. Code dependencies, right? Tree shaking, right? It's a challenge. How do you only include the code that you need? Separation of concern, fixing problems, right? Usually introduces more problems. Okay, so the approach. So yeah, sorry, there's still more about yeah. So the approach we took, I'm just going to go very quickly through this, is instead of reacting to your HTML, we control your HTML. Okay, it's not react, we're direct. Okay, we don't try to be web pages because web pages are documents. It's an application. Code is in markup. It's not markup in code. There's no opinions, meaning literally you can build your application any way you want. There's no monolithic controllers, right? So everything is no magic. No HTML. Some people might look at that as bad. I look at that as good. We're not writing HTML, we're writing an application. So if you want HTML markup, you can include it, but it's specifically not HTML. We look at the HTML DOM as just a rendering engine. It's not wholly whatever. We wrap them. We wrap the DOM. So we have a direct reference, which is extremely helpful in terms of finding what you need and in terms of performance, because you don't have to go find any DOM elements every time you need it. No, it's costly looking for things within the DOM. self-contained. The fact that everything is within one strongly typed framework allows us to do aggressive minification. I mean, we're able to minify things you can't do with more standard ecosystems. Pay as you go, and performance problems easily fixable with components, meaning if you have performance problems, you don't have to jump through hoops to get them. You can say, okay, this component has a problem, let's fix it within that component, and you're done. Okay, some interesting things that I discovered as I was working on trying to optimize. Okay, our number one performance killer in our application were jQuery components. We had 2 jQuery components that took most of the rendering time of our application, just those 2 components. Getting rid of jQuery incredibly increased our performance. SVG elements are way more expensive to create than normal HTML elements. So just be wary of that. If you're creating a SVG, only create them when you need them. Reuse them if you can. Cross-browser SVG support is a little bit spotty. If I would have known about what I knew about SVG now, I probably would have done more of my implementation using Canvas than SVG. But I did. You want to avoid reading CSS properties. Reading CSS properties, depending which ones they are, very often cause reflow. So only read them when you need to. Use your profiler to see if you're causing reflow. If you are, use request animation frame to fix that problem. Fonts are hard. Fonts are hard. If anyone that's played with fonts knows what I'm talking about. One of the issues we ran into was reading fonts into memory. So we originally used a very simplistic approach to reading fonts, where basically we took the font, we parsed the entire font right in the beginning. Just loading a number of fonts, depending on the type of fonts, was causing our application to take between 100. Just the fonts were taking up between 100 and 200 megabytes of RAM in the browser. We switched to lazy loading of the fonts that improved both performance and memory, and now fonts basically take up no memory at all. Yeah, so as part of that, I had an opportunity to learn new data structures. That was interesting. So part of what I had to do was build an XML implementation. I'm not going to get into that; it's going to take too much time. One of the problems of minification is that you have JSON, so that limits how you can minify your code, because basically if you minify your code, you got to change the property names, and okay, whatever, fine. All right, open source, okay, the good, the bad, and ugly. Who recognizes this screen here, right? Okay, what's good about open source? Okay, so I've been involved in open source for quite some time. What's good about it? All right, from my perspective, I get to shape the tools I rely on every day. I got to learn a lot. Okay, got to be forced to learn things that I don't like to learn, and which is good because you need to know certain things. Got an opportunity to learn from from people I wouldn't have had a chance to learn from. Changed the way I look at architecture. So I improved as a programmer because of that. And this was not applicable to me. Well, actually, it was, because I hired some of the people that worked on my team. But many of the team members, they got jobs because they're involved with open source. There's many other, right? There's many reasons that people are involved in open source. So you can come at it from a business perspective. So from a business you gain from it because some of the work that you otherwise would need to do, you're offloading onto other companies. From a developer perspective, so there's a few different classes of developers. There's beginner developers, which helps you get into a certain field. So if you have the field that you're interested, if you get involved in open source, that enables you to, first of all, learn more about it. Lets people in the open source community know who you are. Happens all the time that people from an open source project, they get hired by people from the same open source project or companies that run the project. And so from that perspective, it helps further your career, helps in continued education, and people on the end of their career, it's a good hobby. What's bad about open source? You have to deal with people, okay? Some people are very difficult to deal with. and you can't just tell them to go away. It's very difficult to communicate in online communities because there's no inflection. So if you write something, they don't know what you meant. So you have to learn how to write in a way where they're going to understand what you meant, and very often it's not successful. You're not in charge, so basically you have to take other people's opinions into account. If you like doing things your way, tough. You got to do things even if you don't want to do them. You got to fix things if they break. The vulnerability, I feel bad for those poor Log4j people, all right? Discussions in open source communities are a pain. You end up talking and discussing and back and forth, and nothing ends up happening. Goes with thing. Okay. Some people join open source for various reasons, not knowing why they join open source, and they do stupid things. Yeah. Okay. Now, not all open source is equal. So one of the interesting things about Apache in particular, Apache has a very unique culture. Apache has a very flat culture, so meaning that there is no hierarchy. There's no one on top, there's no one on bottom. It's good and it's bad, right? It's good because everyone has a say. It's bad because everyone has a say. One of the things that Apache doesn't like is what they call beneficial dictators for life, project leads, basically. They don't like people who like being a project leads. So it's bad because there's no project lead. It's bad if you are the project lead because you don't get to say what you want. It's good because it doesn't let people stop projects. If the person that's in charge of the project stops being involved, it can continue. And they have a long history of projects evolving and the core team changing, and that's good. Interesting anecdotes. I was at one Apache conference in my life. I was pretty much fresh out of Köln. And I come there, and I asked someone where the bathroom is, and they pointed to me, and I come to the bathroom, and they say, the women's bathroom, I see men's bathroom, and on the men's bathroom, it says non-binary. It's weird. So I walk in, I figured it's got to be some kind of geek joke, we're at a geek fest, right? So, non-binary, I think it should have been binary, right? So I come out, I ask someone, what's the joke? And it's like, no, you don't understand, right? So yes, that was. People can be nasty, and it's very easy to be passive-aggressive, meaning that you can act nice, but some people are very difficult to deal with, and you need to deal with them, even if they're difficult to deal with. Okay, how to get involved very, very quickly. Just basically find something that interests you. Get involved online. Talk, discuss. Try to contribute back. You learn something. Try to give it back. Start small. It'll build up. Okay. Bug reports. Everybody likes documentation improvements. So if you contribute documentation improvements to any project, they'll love you. Okay. You're confident, a little bit of code, a little more code, once you get involved. Specifically with Apache, if you get involved, if you're noisy but in a nice way, in a friendly way, you'll get pulled into the project pretty quickly. Apache has a culture where if you don't constantly add new people, they look at it as you're not healthy. So projects, specifically at Apache, are constantly looking to add new people. So if you get involved at Apache, then chances are you'll join. So not every project at Apache is going to build everyone, and that's pretty much what I have. Thank you very much, and thank you very much for CityBook for